This video is to show you the solutions to the parametric equations formula. So I'm going to go through each problem. I'm going to work them out algebraically and on the graphing calculator so you can see how you can use both ways to help you solve these. So number one, the two sets of parametric equations correspond to two different rectangular equations. This was a true or false question, and you are to justify your answer if it is false. And so what we want to do is see if they represent the exact same curve. So one way you can do that is to algebraically solve it for a rectangular equation. So taking the first equation, x1 equals t minus 1, and if I solve that for t, I get x1 plus 1 equals t. Now I can substitute that in my y1. So y1 is going to equal 3 times x1 plus 1, and then of course we have the plus 1. And when we simplify this, we get 3x1 plus 4. Distribute the 3 and then add the 1. So what we hope is that the second equation will be exactly the same. So taking x2, and I'm going to solve it for t, so I'm going to multiply everything by 3 first. Add the 4. And then divide by 2. And then I will substitute that in y2. So y2 will be 2 times 3 halves x2 plus 2. And when I distribute the 2, I get y2 equals 3x2 plus 4. So these are exactly the same, so the answer would be true. One way you can do it is also to graph both sets of parametric equations and look at the graph. Now I'm going to go back and forth through this video and use the 84 and the inspire. So let me do this one first with the 84. So you go ahead, you put your calculator in parametric mode. So make sure you switch it to parametric mode, and then you go under y equals and you put in your x1, your y1, your x2, your y2, and you graph. And what you're going to see is, let me just do this because I already did it and you can't really see what's going on here. Let me clear that out, and then I'll put it back in. So if I hit graph, here's x1, y1, and then when I go under y equals again, I'll put the other one in. So 2/3 t, t minus 4/3. And then y2 is 2t. And now when I graph this, you'll see the red line goes right over top of the blue line. So they are the same rectangular equation. Okay, number 2, the graph of the parametric equations, x equals t minus 1, y equals 2t minus 1, where t is equal to, greater than or equal to 1, less than or equal to 3, is a line segment at endpoints 0, 1, and 2, 5. So again, you can make it into a rectangular equation and then check your endpoints by substituting t in. So for this, you're going to do pretty much what we did in the last one. So you have x equals t minus 1. So t is going to equal x plus 1, and then you substitute it into y. So you have 2 times x plus 1 minus 1, so you get y equals 2x plus 1 when you simplify it. So it is a line right now, and it does have endpoints, but are those the endpoints we want? So what I'll do is I'll take my x equation, and I'm going to substitute in 1 for t. So So when I put 1 in for t right here, this 1 will go there. I get 1 minus 1, which is 0. And I'll do the same thing for the 3. I have 3 minus 1. And I get the 2. So there's the 0, and there's the 2. And I'll do the same thing for the y. So I'll substitute 1 in for t in the y equation, and I get y equals 2 minus 1, which is 1. And I get y equals, when I substitute 3 in, 6 minus 1, which is 5. So I get my y value. So this is true. Next equation, and again, you could have done it on the graphing calculator as well. Let me show you that on the Inspire. So here is, you can just trace it. I already traced it a little bit. So I went ahead and I don't know why it's doing that. Okay. I went ahead and I put in the equations, and I changed my t-step. You can see it right there between 1 and 3. And when I did that, I got this equation on the graph. Now to see the endpoint, I want to hit menu, and then I'm going to hit trace, and I'm going to do a graph trace, and you can see it starts at t equals 3 there, and then I'm going to trace, and at the other end I get 0, 1. So you can do it graphically or algebraically. All right, next question. Which of the following points corresponds to t equals -1 in the parameterization? So I apologize if you did this early. There are some problems with Schoology. It was not keeping my math equations very well, and that one was missing, and there's another one later that was missing as well. So all you really had to do was just substitute -1 in for this one. It looked a lot harder than it was, and it wasn't meant to be. And when you do this, you get so you get 1 minus 4, so you get -3, and you get -2. So the point was -3, -2, which I do believe was choice A. Next problem. Which of the following values of t produces the same point as t equals 2/3 pi, 2 pi over 3, or 2/3 pi? In the parameterization, x equals cosine 2 cosine t, y equals 2 sine t. So same kind of problem as number 3. I'm just going to substitute in for t. So x is going to equal 2 times cosine of 2 pi over 3, and y is going to equal 2 times sine of 2 pi over 3. So here's our unit circle. I'm going to have 2 times -1/2, so I get -1, and y is going to be 2 times the square root of 3 over 2, which is the square root of 3. Now you could have tried every one of the answer choices, but what you're going to find is, and the answer choices are, let me just write them out. You had -4 pi over 3 for A. B, you had -2/3 pi. C was -pi over 3. D was 4/3 pi, 4 pi over 3, I'm sorry. I keep saying it that way, I don't know why. And E was 7 pi over 3. So really, what you had to do is, remember where 2 pi over 3 is. You're here in the unit circle in the second quadrant. Which of those angles, since they're all pi over 3 angles, is in the same place? And it would be this one, because you need a -x and a positive y. So it would be A, because -4 pi over 3, starting here, would take you up to that point there. Okay, next, number 5. A rock is thrown straight up from level ground with its position above ground at any time t is greater than 0 given by x equals 5, y equals negative 16t squared plus 80t plus 7. At what time will the rock be 91 feet above the ground? This is simply a calculator problem, and I'll do this one in the 84. So going under y equals, I'm going to clear all these out. And go back up to the top here. And I'm going to put in 5 for x, and then y is negative 16t squared plus 80t plus 7. Now, as far as a window goes, this is why my window for number 1 was messed up. I did this window ahead of time. I let my t go to its normal t. 0 to 2 pi is 360, because I have my calculator in degrees from things we were doing in section 1. Let my t step alone. There's only one x value, x equals 5, so I just put it at 6, a 0 to 6. And by y max, I wasn't sure how high the rock would go, so I picked 200 and counted by tens. So now when I hit graph, I'm going to see that the rocket is going to go straight up in the air, as you'd expect. So now I'm just going to trace the graph, and I want to know when is it the y value at 91 feet. So I hit trace, and you can see at the bottom of the screen at t equals 0, x is always going to be 5, so you don't have to look at that. And the rocket started 7 feet above the ground. So then when I trace along this, you can see the y values are getting bigger and bigger, bigger. So I just want to see how close I get to 91 if I have to start messing with the t value. And the nice thing is, this problem was designed so it's pretty easy to find. So when t is 1.5 seconds, the rocket is 91 feet. So the answer to number 5 is 1.5 seconds. Okay, number 6. Which of the following describes the graph of the parametric equation? X equals 1 minus t, y equals 3t plus 2, t is greater than or equal to 0. So again, you can change this from parametric to rectangular. So in this case, x, taking my x equation and solving for t, you get that t is going to equal 1 minus x. If I just bring that over there and this over here. And then y is going to be 3 times 1 minus x plus 2. So distributing the 3, you get y equals 5 minus 3x, and that looks like a line, but when you take into account that you want t is greater than 0, what you're going to have is a ray. So I think I put that one here. Yes, there it is. So it's going to keep going. If you look at our equation, the bigger t gets, the smaller, well, it's probably easier to see here. The bigger t gets, the smaller x is going to get, because t, we're going to be greater than 0 here. So all the numbers I put in for t are positive. So I'm going to have 1 minus and a positive number. So x is going to get smaller and smaller. So in my graphing calculator, this graph is going to go to the left as I get a larger t value. So you can see it there. But it has an endpoint. So what kind of graph looks kind of like a line with an endpoint? And that is a ray. So that's why it's a ray. Okay, and then number 7, you just had to eliminate the parameter, identify a graph. And I did one of these in the homework, I do believe. But the idea here is since the x equation is more complicated, put t in from y into the x equation. So x is going to equal 3 minus 5 times y squared. So this is a parabola that's on its side, and again, you can put this in your calculator in parametric mode and it'll look like that. So let's just go ahead and put that in the Inspire real quick. I didn't do that ahead of time. Oops. So change it to parametric mode. I'll do this. Yes, it's actually a good thing because I haven't put one in for you guys this way. And so you would put in 3 minus 5t squared for x, and oops, I always put enter there instead of tab. You got a tab. And y is t. And we are given boundaries on our t. No, we are not. So I'll just leave it the way it is. If I want to put some negative values in, I can. I think I'll do that. Yeah, I think I do need to do that. So I'll just make it -6 to be kind of symmetrical. And when I hit enter, you just have to match it up then with the graphs. So that's what the graph looks like, and I do believe it was graph A. And then finally, the last question. Choose the correct parameterization of the line segment below. Okay, so we just have this line segment, and we're going to use our little formula here, or you can draw the vector picture that we did in the notes. So I'm going to use the fact that x is going to equal a plus t times c minus a. So this will be a, this is c, there's b and d. And so y is going to be b plus t times d minus b. So now substituting, we get that x is going to equal 1 plus t times 6 minus 1. So our x equation is going to be 1 plus 5t. And then our y equation is going to be 5 plus t times -4 minus 5. So we get 5 minus 9t. And then it said it was a line segment. So you had to choose. There were two answers. I don't know why I didn't put the multiple choice answers in. Answer A was this equation, these two equations here, but we had this set of t range, and letter C had this t range. So the answer had to be letter A because it had this equation, this set of equations, and we wanted a line segment, so we needed endpoints. Letter C would use this set of equations, but it would be a line because there's no endpoints. So hopefully this helps for those of you who had some questions on the warm-up. Have a great weekend.